Ciao friends! In this session we will see how to choose between Direct Lake and Import mode for your semantic model. I delivered this content in a session at the Microsoft Fabric Conference 2025 in Las Vegas. But the room was fully packed. Many people were outside and were not able to enter for security reasons, and the session was not recorded. So I promised to all the attendees of the conference, but also to the people that were not able to attend the conference, that I would have recorded this session after the conference when the feature would have been released. Because in this video we will see a new feature, a new type of composite model, which is Direct Lake+Import mode. So let's start with the session. How to choose between Direct Lake and Import mode was the name of the session. But I added a subtitle, from May 2025 onwards. Why? Well, we have many choices, many different choices of storage mode, because there is no silver bullet. Every choice has pros and cons. And depending on the requirements, depending on the priorities, we might want to make a choice of one technology over another. So at the beginning, we will review the existing architectures and their constraints. And then I will be able to introduce a new type of composite model called Direct Lake+Import mode. Yes, because we can combine Direct Lake and Import within the same semantic model with different tables with different storage modes that don't pay the price to traverse the boundaries between two different semantic models. In other words, all the tables will be like they are imported, even if a few tables are in Direct Lake mode. So the structure of the session is the following. We will start looking at the import mode, how the import mode works. Then we will see how Direct Lake works. We will also spend time looking at how we can use the current tools, the current technology to create and maintain the models. And then I will introduce an example where I combine within the same model tables in Direct Lake and in Import mode with a classic composite model, which means that we would have to combine two different semantic models using a third one that includes tables of both. But we will see that this comes with a price, and we can avoid to pay the price with the new type of composite model, which is Direct Lake+Import mode. Let's start reviewing the architecture of the import mode. In a business analytics solution, we have always one or more data sources which contain the raw data that we want to analyze. But this data is usually not in the prepared form that we want to use in the semantic model. So we could have files, services, OLTP databases. And all these data sources that, if you use the medallion architecture, this could be the bronze layer of your medallion architecture. Well, this data must be transformed, must be prepared, must be refined. And what we get at the end for a semantic model is usually what we are used to call a data mart or a dimensional model. And for those of you used to the medallion architecture, you could think about the gold layer, for example. And in order to populate this different structure of data, so the data model is different, we have to copy and transform data. So this is something that doesn't really belong to the import mode. This is something that is common to all the models that we will see. But I want to highlight that this is a necessary step, because this will be important when we consider other alternative options, where some part of this could be eliminated, but some other part cannot, like, for example, this copy and transform data that I'm mentioning now. So what we obtain is a different structure that could be in any format, any storage. Back in the day, we might have had to use a relational database, but nowadays we could use a Parquet file or text files in a data lake, for example. And that is not really important for the semantic model, because the important part is that, especially for import mode, we have data in a certain structure. We don't care about the storage, the actual storage of the structure. because the semantic model that will expose this data to the end user, to the reports, is something that has a local copy of the data, the private storage. And the private storage actually is a storage that has a number of characteristics. It has a high compression. It has the best performances when we import data in the Vertipack storage. Because as you see in this slide, and let me highlight this, Vertipack is the key. Vertipack is the internal storage engine for the import mode, because import mode actually copies the data from the data mart, the dimensional model, the goal layer, call it as you want, but this is a copy of the data in a physical storage that is very optimized for any kind of workload that you might have on this semantic model. Now, this private storage, which is a private copy of the data, has pros and cons. What does it mean? Well, because there is a copy of the data, we have to spend the time to read and compress this data. Optionally, you could have some transformation. For example, you might have, if you use Power BI Desktop or Power BI in general, you could have a Power Query transformation so that a certain column is modified. You might get only the first 3 letters of the month name, or you can generate the month name out of the blue because you don't have the month name stored as a column in the initial storage that you use as a data source for the semantic model. And I highlighted in the slide this part, the compression. The compression is important because it doesn't matter if the data is compressed or not in the storage where we get data from. Vertipack will create its own compression in memory with a columnar database that is highly compressed, very optimized, and very efficient. And so the thing is that we don't have to spend time worrying about that. The compression is something that we get for free when we import data. For free means that we don't have to tune anything. Everything is automated, and Vertipack already produces a very good high compression for your data that is also very efficient with what I call zero maintenance, or let's say low maintenance. If you have a complete full refresh every day for your model, we could say that you have zero maintenance. If you have an incremental refresh, you might want to spend some time doing some tuning or some, let's say, update of the indexes of the calculated tables and dictionaries and so on, because over time there could be a degradation in the way the data is stored in the dictionary and also in other structure if you use the incremental refresh and you never do a full refresh. So we say, okay, low maintenance in those cases, just to clarify what these terms mean. Now, the entire model and the data can be stored in a local PBX file. Now, this solution is the one that has the highest compression and the best performances. Keep in mind, Vertipack is really the king here. We will not find a solution that works faster and better from this point of view. But of course, there is a price to pay, which is we need to do this step, which could take a long time, especially if we have a full refresh to do every time. But sometimes also the incremental refresh could be expensive because we might want to do some other transformation. However, this is also an option. During the refresh, we don't not only read data and compress data in memory, but we also compute calculated tables and calculated columns. That could be helpful to create structures that are, let's say, helpful only for the semantic model, but will not be useful outside of the semantic model. Think to a particular pattern for optimizing the performances of certain scenarios, or to provide to the user a specific access to a certain custom grouping of data that you don't need to expose outside or something like that. So there are a number of cases where calculated tables and calculated columns are an effective way to solve a modeling problem, because they are part of the data model that is just for the semantic model, and it would be meaningless outside of that. So long discussion, I don't want to spend too much time on that, but let me just recap the key points for the import mode. Key points is that it's simple It's simple. You don't, I mean, you get the tables done. It just works, right? It just works, and it works very, very well. You don't have to pay additional time for administrative efforts and so on. Now, this is the default mode. The import mode is the default mode for traditional data sources. So if you get data from SQL Server, Excel, usually that's the first option you have. But if your data is stored in Fabric, in a Lakehouse or in a warehouse, this is not your first option. Your first option is probably going to Direct Lake. But when you go there, as we will see, you have other limitations. So if you don't want to have any limitation, you can still import data from your Lakehouse if you want. You can. We will see how to do that. And you also can apply Power Query transformation when you use the import mode. We will see that, for example, Direct Lake doesn't have this option. And so we have access to all the features. Basically, it's the native mode in which Power BI has been designed, and so it supports all the features this way. It's very optimized. I already mentioned this in the previous slide, and there is a processing overhead, and the format used to store the data is an internal binary format, which means that you don't have a direct access to that raw data, compressed data format. You always have to go through the DAX query. Or an MDX query if you prefer. But you don't have SQL, for example. If you want to create a query in SQL to query the data that has been compressed in Vertibac, you cannot. Something that we will see you can do if you use Direct Lake. So this is more or less the complete description, but let's take a look at how to create a model in import mode getting data from Lakehouse. Because the entire demos that I want to show you are based on a Lakehouse where I have my Contoso data model, and I want to explore the different options starting from the data that I have in a Lakehouse or in a warehouse. So let's create our first model in import mode, getting the data from our Contoso database that is stored on a Fabric Lakehouse. With this will be in import mode, remember. So we start getting data from the OneLake catalog, and I choose just to filter the lake houses, and I filter by Contoso so that I will choose the Contoso that I have in my Fabric demo workspace. Now, first important point, you see that I don't click connect immediately, because if I click a connect, I will have connected to OneLake, which we will see later with the Direct Lake approach. Now we are doing the import approach, and in order to import the data, I have to start with connect to SQL endpoint. Basically, this way, from the Power BI desktop point of view, we're connecting to a SQL source. So the queries are sent in SQL to the SQL endpoint of the Lakehouse. So when I click this, I get a connection which seems like a SQL connection, and I choose just the tables that I want to import. So these 5 tables, including products. And I go to transform data. I could use load, but I don't like the names because the names are all lowercase, and I don't like them. Before changing the name, you see that I have to choose between import and direct query. If I choose direct query at this point, I will create what is called a Direct Lake over SQL endpoint, which is, let's say, the classic way to create Direct Lake. Nowadays, we have a better way that we will see in the next example. So at the moment, I start with import mode, so I just copy the data into the proprietary format of Vertibac. Now, as I said, I just want to change these names, so products, stores, and so on. And I will also make a small change. The data that I'm using have like 2 million customers and 100 million of transactions in the sales table. And if I import all of these transactions, I don't have a real problem for that beside the time. It will take a lot of time. And so I don't want to spend so much time just importing the data just to show a quick demo. So I will filter both customers and sales, saying, well, I want to get the customer key, let's see if I am able to do that, less than 20,000. So by creating an artificial filter over the customer key value, I limit the customers that I load and also the rows in sales that I want to load. So I go here, customer key, and I apply the same filter. So this way the data will be consistent, and I put here 20,000. So once I do this, I can click close and apply, and I can refresh the model, apply changes. So I wait that the data is loaded in memory. Remember, as I said, at this point, the data is transferred from OneLake going through the SQL endpoint. It is received by the engine of Power BI, the tabular engine, the same analysis services engine that runs also in analysis services and Power Pivot. And the data is compressed in memory and stored, in this case, in memory. You see that I already completed my job. You can see that in products we have, so not in products, in customers. In customers we have exactly 20,000 rows, and in sales we have something more than 1 million rows. Okay, which is good enough to create our example in import mode. But now all these tables are disconnected. So you see that we have actually, sorry, it is not true. So the tables, a few tables have been connected by using columns that have the same name and the same data type. And so you see that there is already a connection between products and sales, between stores and sales. This connection has been created just because of the name of the columns and their content, not because of some relationship that was in the database, because the Lakehouse doesn't have these relationships. And the only missing relationship is between sales and date, and I want to connect the order date to date here, and I think this is enough. So by connecting these two tables, I have my semantic model ready. However, at this point, I also want to create measures. And in order to create measures, I just prepared a small script where I have the measures that I want to include in my model. I could create these measures one by one, but I have a smarter way to do that. I can just copy and paste the list of the measures I want to create in a separate calculated table that I call M with the list of the measures. And I just apply this, and I have my measure applied. So I just refresh this calculated table, I go back here, and now you see that in M I have my measures already created. So this is a way to make the demo shorter when I do this on stage. So let's create a simple example just to see whether we have the data that we want. So we have the sales amount, we have the total cost, the margin percentage, and we also may want to change a little bit the font of this so that it is more visible in the screen. So let's use a 20 as a font size, and also we can add something in the rows. So for example, I could get, for example, I don't know, the product brand, just to see that you see that every action I perform, the result is very, very, very fast. Remember, I'm working with a local copy of the data in my computer, in my local computer, in my local desktop. So at this point, I want to save this file. So let's save this file, save as, and I want to save this in my C demo, and I call this, let's call this, let's create a folder, Direct Lake demo, and I call this import mode. Okay, demo import, okay. Okay, so I just copy this in the clipboard because I want to show you. Let's open a File Explorer. I move File Explorer in this screen, so you can see that in this file, this file is 21 megabytes of size. Okay, so the size of this is a small fraction of the amount of data that we have in the real model. Of course, if I wanted to import the full model, I would have imported more than 100 million rows, and the size would be much, much larger than that. Now, at this point, I have the measures, I have the relation, I have everything. I can just publish this model. So I go to File, I go to Publish to Power BI, and here I just select Fabric Demo, and I publish the model on my workspace. Now this takes a few seconds, and both the data and the report are published to my workspace, and then I can use this model to create a new report. But at a certain point, so if I open this in Power BI, just to take a look, I have here exactly the model that I published, and I can navigate. And everything is in the cloud with a copy of the data that I had in my initial Lakehouse. Now, what if I want to create, though, a report where I want to analyze the data by product price, for example? Well, I might realize that if I use the product price, so if I put the price here in the rows, what happens? Well, I see the unit price, but actually there are too many different unit prices. I probably want to create just a range of prices. And this could be the classic problem where we have a reporting requirement that drives a change in the data model. If I want to group the price by, I don't know, 1 to 10, 10 to 100, and something like that, I need a column. I cannot just create a measure. And the column is part of the semantic model, and the column must be a physical element in the model. Now, if I use import, that's not an issue. I have many ways to do that. I could use Power Query. I can use, for example, a calculated column to do that. So I can go to my product table, and let's show this here. If I go in the product table, I create a new calculate column. I can create a calculate column where sorry, not in sales, in products. In product, I create a new calculate column where I paste my code that I prepared, where I have to evaluate, products. That's another problem. I forgot to rename the tables using the singular word. So instead of customer dates and product, I would have used customer date product without the S. And so I had to fix the code that I mistakenly prepared reference, not mistake. I correctly prepared using the singular. Now I have the mistake in the name, but I can fix it. And I'm assigning a different price range price range, let's say key, that is 1, 2, 3, 4, depending on the scale of the price. And I create a very similar column. I call this other column price range, that is the one that I want to show to the user based on products, price range order, and then I arrange this sort order by price range order. Here we go. So by doing this simple operation, and probably I want to also hide this column here, so I can right click and hide in report view. When I go back to the report, you see that only price range is visible as a column here, not price range order. And if I replace price with price range order, I have exactly the classification, the grouping of the products according to their price based in ranges 1, 10, 10, 100, 100, 1000 with a corresponding name. And you see that they are not sorted in an alphabetical order, but they are sorted according to the price range order that I provided. Keep in mind, in order to do that, I had to change the data model. This is very important because the business requirement, the reporting requirement, require me to add 2 columns to 1 table in the semantic model. This kind of change is not something that can be useful and helpful to every other user of the same table in the Lakehouse. So potentially this is a change that is specific for this model, and I would like to keep specific for this model. I could use a view in SQL. I could use a Power Query transformation. I use DAX, but I will not spend the remaining amount of time just talking about should I use a calculate column or not. The point is, the original table was not good enough. That is the important point. And I just use one of the many tools I have available to create the model that I need just for this semantic model. But these 2 columns probably don't make any sense for other semantic models based on the same product table in other departments of the same company, for example. So that's a way to highlight why this could be important. And let me publish this model again. So I can publish this model to Power BI again, and I can just replace the previous one. I can ignore this. This is a small bug, and I just I don't remember if I published this or not. Let me try again. Sorry, it saved that. That was the reason why I had the error. So there is a warning. I replace, I save, and this is fast. But again, every time I publish the model this way, I am copying the entire model. Of course, if the model was big, I probably would use a tabular editor. I would use analytic in place in the Power BI service. I could use Tyndall now, but again, I have to find a way to optimize my flow, my process to prepare the model. But this is how the import model works. I have an entire copy of the data. Now it's time to talk about Direct Lake. We're going to create the same model, but this time by using Direct Lake mode. And before looking at the steps from a practical point of view, let me describe from an architectural perspective what happens when we use Direct Lake. So the initial part is the same that we described before. We have several initial data sources, relational databases, file services that have a structure of the data that is not good for the semantic model. So first of all, we have to copy, transform, and now compress the data. Because if we want to use Direct Lake, what happens is that we will connect directly to the data stored in the Lakehouse. And so not only we have to copy and transform the data, but we also have to compress the data. And the compression is required to store the data in the format we're going to use for the dimensional model, the data mart, the goal layer, if you prefer. And what happens? What happens is that this data is stored in either a lakehouse or a warehouse on Fabric, and this storage is actually compressed. Now, this compression must be made here during the load of the data in the Parquet or Delta format for the Lakehouse. The data format is the one used by Direct Lake. And the difference is that when we create the semantic model, what happens? The semantic model now has a description of the modeled metadata, but it doesn't have a copy of the data. The data is kept on the Lakehouse or on the warehouse. However, there is a refresh needed. There is a refresh needed for aligning the metadata. So this step is called reframing. So whenever there is some change in the Lakehouse, there is a discrete operation that must be made on the semantic model to say, oh, look, there is some change, refresh your metadata, and invalidate what you had before, also in terms of cache. Now, but where is the data? Well, the data is kept on the Lakehouse until a query happens. When some query wants to read the data is actually moved to Vertipack. So this operation happens when you query the model. However, because the data stored in the data format in the Lakehouse or warehouse is very similar to the physical storage of Vertipack, the operation is called transcoding. There is a quick let's say, during the query, the conversion is made between a compressed format to another compressed format that is relatively fast. So is slightly more expensive than just loading the data from a file, like a paging operation, but it is not as expensive as the full compression of the data. We don't have, not we, but the engine doesn't have to prepare a new dictionary and so on. It has just to refresh the Vertipack model in memory based on the information on the data Parquet format. This operation of data movement at query time is called transcoding. And the name implies it's not free. It takes time. So when you think about Direct Lake, the first thing that you should learn and understand is that in the best case scenario, it will be as fast as import mode. It cannot be faster at query time because actually it is the same Vertipack engine that just get the data from another format with a transcoding. So it has to be slow. It cannot be faster, right? Because there is an additional operation. And moreover, now the freedom of, so this is, of course, we save time. We save the time for the full refresh. If we compare the two models, what we see? We see that now the compression is moved here. The compression is moved here, is moved during the data preparation. And so operation of import mode creates a copy of the data. The refresh operation translates the full amount of data. The compression is in charge of the engine. Whereas in Direct Lake, we have the refresh operation is just a very quick operation that updates the metadata and invalidates the data that we have in memory in case a transformation required to drop the data already transcoded in Vertipack, and that has to be read again from the Direct Lake engine. So again, there are pros and cons, and of course, with the Direct Lake, we have a big advantage. Even when the model is very big, a full refresh is immediate. So the refresh time doesn't depend on the amount of data that we update in the incremental refresh is very quick. However, you probably have to consider that there is time required to prepare the data, to transform the data into the dimensional model. The time is still there, but from the point of view of the semantic model, you don't pay an additional price to create a second copy of the data. This is true. However, because now we connected Vertipack straight to the data parquet format, we cannot use Power Query to transform data during the loading. We cannot use calculate columns, calculate tables, at least at the beginning. We will talk about this later, because the calculate tables and calculate columns will come to Direct Lake, but they are not available yet. And there is also some limitation when we use Direct Lake. There is some limitation for people who use Excel to connect to Direct Lake. Specifically, the user-defined hierarchies are not available, which means that if there is a hierarchy defined, for example, between different columns of the table, that is not immediately translated into a structure that is available for the Excel users. So there is some limitation that could be annoying for the Excel users. And also the drill-through in Excel is not supported. That's the internal drill-through. We're not talking about the drill-through in Power BI, which is another thing. We're talking about the drill-through in the semantic model that is exposed to Excel, and that is not available if you use Direct Lake. Transcoding is needed, I told that, and I would like to spend a few seconds about the compression quality. Because the compression is in charge of the developer, now, depending on the technique and the tool and the libraries used by the developer to compress the data in the Fabric Lakehouse or warehouse, you will have a better or worse compression, which also reflects in better or worse performances. Because a very good performance relies on a very good compression. If the data is not compressed well, then you might be in trouble. And not compressed well doesn't mean only using the best library, means only using the best approach to, for example, incrementally refresh the data. If you continue to add one row at a time in a table in a delta format, the compression will be very bad. You probably want to consolidate chunks of data where if you have a multiple operation on a small number of rows, over time you want to consolidate data. So you have to expect more maintenance to keep the data in good shape for the compression in your warehouse lakehouse. Okay, so that's something to keep in mind. It's not good or bad, it depends, right? So it's just something that you have to consider. And so more attention for this. So let's start looking at how to create the same model using Direct Lake. To create a model in Direct Lake, I can just use Power BI Desktop. And with Power BI Desktop, I use the same color that we have seen before. I connect to the same lakehouse I chose before. So I choose, for example, Contoso, and I click on Contoso in Fabric Demo. And this time, I use Connect to OneLake. By using Connect to OneLake, I will create a model in Direct Lake. Pay attention, because I'm not creating a local model. A model in Direct Lake is stored on Power BI Service. So I will use the Power BI Desktop user interface to create a model straight on Power BI Service, on the workspace in Power BI Service. So I click on Connect to OneLake, and at this point, I see in my Power BI Desktop the list of tables I have here. So you see that now I have to choose the name of the semantic model that will be immediately published live, immediately. And so I call this demo Direct Lake, hopefully is not already used. I will check in a moment. And I choose the same tables: customers, dates, product, sales, and stores. I click OK. And at this point, my tables are made available here in Power BI Desktop. Just a few seconds that is available. And even if I don't have the Power Query transformation, I can still rename the tables. Because remember, I wanted to rename the tables because I don't like having these names in lowercase. So here are my tables. I can go here in tables and I can just start renaming them. So this is customer. I like the singular. So date. I like the singular. Products. The idea is that I use the singular for the dimensions. I use the plural for the fact table. This is the convention we usually use to make it easy to have meaningful names, but at the same time also names that we can decode without having D in fact, FD, and these prefixes that are nothing good for the business, and store. Okay, because we want to present this data, so it has to be nice to read. So at this point, you see that this warning is telling me that I'm live editing my model in Direct Lake because what I'm doing is already published, already available in Direct Lake. And now, another thing that we have to pay attention to, we don't have any relationship. In import mode, some relationships are created automatically by checking the name of the columns. Here we have to do this manually. So I'm going to create a connection between sales, order date, and date. We have to pay attention. Many to one in this case is good. Sometimes you have the preview, but sometimes it takes too much time, and during this demo I don't want to spend time waiting. So I go to product key with product key here. Here we go. Many to one, yes, because it's many to one. I move forward, so store key, here we go, store key, oops, so let's go to store key, oh, sorry, here, store key. You see that I start from the many side and I go to the one side, so I don't have to think too much about the options here before I see the preview. And finally, I have, there is something missing here, here we go, the customer is here, so customer key to customer key. Here we go. Now we have all the relationships. We created a 4 relationship between the fact table and the other 4 tables. I need the measures. So I copy the, let's see, where is my mouse? I copied the code I used before, the same Tyndall code that I used before to paste the definition of the measure in a calculated table. Wait a minute, we're using a calculated table in Direct Lake, right? Yes, but as long as it is a fake calculated table just for the measure, it is fine. We're not reading data from other tables, so that's a kind of calculated table that is supported. And as you see, after we apply this Tyndall script, we also have to refresh the new calculated table that we have. Okay, so let's remove these warnings and let's go back to the report. Let's see if I made everything. Yes. Now the thing is, here I don't have I have just the preview of M, which is an empty table because I created an empty table with the measures. The measures are here, right? The measures are here, and I have the tables. But if I go to the table, I don't have a preview because the preview is not enabled when you are in Power BI Desktop. How do I create the report? Well, I have to go to the cloud. So let me open a window with this model. So I go to the model, let me 1 second only, and I move this here. So this is my Fabric demo workspace. I have the demo Direct Lake semantic model I just published, and I can go to this model, and here I can use explore this data. Explore this data just create a dialog box where I can see, for example, my product category name in the list of the names here, and I put the sales amount, the total cost, the margin percentage, and in a few seconds we will see the result. Pay attention, this is not immediate as it was with the import mode. 2 reasons for that. One, the data has to be transcoded, and this takes some time. Moreover, because this is the first time we actually access this data in the Lakehouse. If you remember, before I imported the data, but I imported filter data. So actually I didn't get the entire amount of data. This time I had to get the full content of the table, because now I'm getting 2 million customers and 100 million rows in the sales table. Indeed, if you notice, the numbers are bigger now. But once I, let's say, warmed up this model, now the data is in memory in Vertipack, in the semantic model. While I have this model in cache, the query should be relatively fast. You see that now, as long as I don't add a new columns, because new columns have to be moved and transcoded, the performance is relatively quick. Just to make a test, instead of the category name, we can, I don't know, we can get the customer continent here. And you see that the customer continent now takes some more time. Remember the transcoding. Transcoding means that we have, the data has to be moved from the Lakehouse to the, let's say, internal Vertipack engine, and there is a transcoding happening. This takes time. Now we also have an error. That's fun. That's funny. This is not what I expected. Oh, okay, some error getting the access to the Excel file. No idea what is happening. So let's try again. This was not planned. I will keep in the recording because this could be something related to the size of the data or to some other error. So let's try to go back to something in the product, for example, so that we get something smaller, like, for example, the product manufacturer, for example, just to see whether it works. Hopefully, yes. And the manufacturer works. So you see that usually I would expect not a slow performance like or an error like we have seen before, but this is just to give an idea. So the difference between import mode and Direct Lake is that now the data, there is some latency the first time we access some data that we never queried before. Of course, if you have many users, they use the same reports, probably nobody noticed that, but this is something that you have to know, because in different cases, this could be important. Now, let me go back 1 second to the Power BI desktop model, because if you remember, the next step was, okay, now I want to create the price range, right? We used a calculate column for the price range, and now if I go back to product, you see that I don't have new column. New column is disabled. We cannot create a calculate column, we cannot create a calculate table in a Direct Lake model. We cannot use the Power Query because we don't have any transformation between the data source and the semantic model. So what we have to do at this point, we have to ask the people that populate the data in Direct Lake to modify the table product. Please, can you add a column called the price range to the product table so that I can have the price range. I need these two columns with this content. And of course, someone will do that, but in an organization, if you have many people working on a project, probably you, semantic model developer, you are not able to do this change, even when you have the skill to do that, because you are able to modify the Spark transformation or the SQL transformation you have to prepare the data. You might not have the authorization to do that. And so you might have to wait someone else to prepare the data that you need. And guess what? Most of the times, this operation, this aesthetical transformation of the data is something that is needed for the report that requires a physical transformation of the model, but just for the report. It doesn't add, let's say, a meaningful information for other reports, but it's still a physical information we have to prepare. Many dimensions have this requirement, and the dimensions usually are small, so they are not really a problem for import mode, but those are the elements that benefits more from the flexibility of the import model. Whereas in the fact table, well, the fact table, we hardly, almost never, extend a fact table creating columns. We just create measures on the fact table, and the fact table is usually the bigger one that we don't want to load every time. So probably I would like to have the fact table in Direct Lake mode and the dimensions in import mode. We will see this at the end, but this is where we're going, right? So now, let's go back 1 second to the slides, because I want to talk about the different flavors of Direct Lake. Because now we used what is called Direct Lake on OneLake. Because this technique that I used basically doesn't have any fallback to direct query. If there is not enough memory to load the data, the server is too busy, you just get an error. Maybe the error that I have seen before, but I'm not sure that was the problem. And this Direct Lake on OneLake is also becoming the default mode, because it's the mode that also supports and enforces OneLake security, which is still not available in full, but it is coming. So OneLake security will be supported primarily for Direct Lake on OneLake. And if you look at the expression in M that load the data, the only difference between Direct Lake on OneLake, which is the new mode, and Direct Lake on SQL endpoint, the mode that has been presented 1 year ago and now is probably going to disappear for most of the use cases, is just the M expression that connects the table through the Power Query transformation. The Power Query transformation, the Power Query connection, not the transformation. The Power Query connection is based on SQL.database when you use SQL endpoint, and Azure Storage Data Lake when you use Direct Lake on OneLake. And if we use the, let's say, old way, the Direct Lake on SQL endpoint, what happens is that if there is not enough memory, then there is a fallback to Direct Query, which means that now in those conditions, the query will be redirected to Direct Query over SQL and will become a SQL query that is sent to the SQL engine over the Lakehouse or the warehouse. And in that case, there is also an enforcement of the SQL-based security if you have SQL on that side. Now, what does it mean from a practical point of view? Probably we have seen in the demo, I tried to highlight, but having the slides can help. Using Direct Lake on OneLake is activated by the option Connect to OneLake you see highlighted in the slide. When we use this technique in Power BI Desktop, we create the model in the Power BI service, so we don't have anything local, but we use Power BI Desktop as a user interface. It is not possible today in Power BI Desktop to create a model using Power BI Desktop but through SQL endpoint. So if you want to use the SQL endpoint, you have to go, if you want to use a Direct Lake over the SQL endpoint, then you have to go to the Power BI service. In Power BI service, you can use the new semantic model button that you see in different places of the user interface, as you see in the slide. But this option is not, with Power BI service, it is not possible today to create a model using Direct Lake on OneLake. As of May 2025, I expect these limitations to be lifted in the future, especially for Direct Lake on OneLake. Not sure that they will increase the support for Direct Lake on SQL endpoint, probably not, but that's my speculation. I don't have information from Microsoft about this. Now, what about editing the model? Can I edit the model in Power BI Desktop? Yes, and you can do that for both. You can edit a model that has been created with Direct Lake on OneLake and Direct Lake on SQL endpoint. In both cases, you can using edit. When you connect Power BI Desktop to an existing semantic model, you can just choose edit, and you will edit the semantic model using Power BI Desktop. Otherwise, you use connect, which is the other option, because you just want to create a report connected to the semantic model that exists published on your workspace. What if you want to edit a Direct Lake model in Power BI service? You can by using Open Data Model. If you open the page with the semantic model, you click on Open Data Model, and that is available today, May 2025, for Direct Lake on SQL endpoint. It is not available yet, but it should be coming soon with Direct Lake on OneLake. We can just try. If I go to the window that I used before, this one, I close this preview, I don't save it, and I use Open Data Model. Actually, we are in viewing mode. Changes will not be saved. Oh, it is already available. Sorry. This my note in the slide was March 2025. I didn't update this on time for recording the slide. So now, good news. We can actually, hopefully, we can. Yes, it can, because it works with. Yeah, we can edit the model also in Direct Lake on OneLake. Very good news. I will update the slides later, but probably what you see in the recording will not change. So let's go back to the slide. So what about importing tables from a Lakehouse warehouse using Power BI Desktop? If you remember, this was the first demo. I wanted to import data using data in the Lakehouse. So the steps are the following. First, use connect to SQL endpoint. But then, instead of using direct query, choose import. Okay, so this way, we import the data through the SQL endpoint and the Lakehouse. And if I want to use direct query over a SQL endpoint in Power BI Desktop, I can. I just have to use connect to SQL endpoint and direct query. So this is more or less a recap of these options. I think that this is useful as a recap because I remember when I had to study this, I was extremely confused about the different options that we have. My suggestion is to use Direct Lake on OneLake when you can, and you want to use Direct Lake, and just pay attention to the right option, which is also the default now for open and connect. So it should be easy, but this way we clarify, especially for those of you that used the Direct Lake over SQL endpoint in the past. Now, this slide just recap what I mentioned before, which is what if I have to create this additional column? Sometimes we just want to change the sort order of a column, or we want to shorten a string that is too long for the reports. You might have the full month name in a table date, and you just want to display 3 letters in the report because of a space constraint. And these changes actually require a change in the semantic model, in the physical model of the tables in the semantic model. I like to call these aesthetic requests. So custom grouping is already an advanced one, but sometimes it is just a very, very simple transformation of the name because it looks nicer. And there is nothing hard to do. The problem is the organizational issue of these changes. Because if you look at the different roles that you might have in a company, if you have the data engineer that is responsible for what we see on the left of this side, where the data engineer is responsible to prepare the data on the Lakehouse or on the gold layer, let's say. Then we have the semantic model developer who is responsible for creating the measures, the relationships, the nice presentation of the data. Well, with the import mode, the semantic model developer has access to the transformations, the last mile transformation for aesthetic reasons that is not available today in the Direct Lake mode. And in the Direct Lake mode, we could rely on what? We could rely on materialized views. These materialized views have been announced at Fabric Conference. At the Fabric Conference, I have a few slides to describe that in a moment. In the semantic model, as of today, we don't have tools. However, Microsoft announced that there is a plan to implement both calculate columns and calculate tables. Actually, calculate tables will be released sooner than calculate columns for Direct Lake. So once I have calculate columns and calculate tables in Direct Lake, I have more options. And then once again, there will be pros, cons. We will record another session at that point. Because the reason why today I will show you how to use the combination of Direct Lake and import mode is because I want to mix Direct Lake for a fact table where I don't need to do any transformation, but I want all the dimensions imported in memory for performance reasons, for features, because I want to use Excel full feature, and I want to be flexible in adapting the model to any kind of business request without having to wait for the data engineer to prepare the data for me. That's the reason why I want to use this. So one idea is to create a materialized view on the Lakehouse. Now, I go back one slide. The materialized view, which is what I'm highlighting in this box, is a feature that is still not available, but it will be available hopefully soon. It has been already announced, but that is a feature for the data engineer. Sometimes, again, this feature, the materials table, doesn't completely solve the organizational issue where we want to be able to autonomously create new tables, new columns for the semantic model. We need someone else to do the job for us. Of course, in certain cases, you have the authorization to do that. That's fine, but that's not the general case. So how this feature is going to work? Well, the idea is that you create like a view on top of the table, and this view today is like a view in SQL that you can import. So instead of importing the table, you import the view in SQL. Now, this is the classic way to import the data. And Direct Query doesn't have this view available if you use Direct Query. Or better, if you use the Direct Query is available, Direct Query on SQL endpoint is available only for a physical table. If I want to create something that goes on this sort of view, once the materialized view are enabled, when you connect to the view, what happens is that the view is materialized in a physical table, in a physical delta table, and then this table is used by the semantic model. So that's the idea, having something that works automatically, we would say, to have the table that has a transformation that we want. But once again, think about this. You will have 5 semantic models based on the same tables in the Lakehouse. In the same Lakehouse, we will need to create multiple versions of the views, one for each semantic model. And so in a way, this is, I don't know, this is not the best option from my point of view. But of course, once this is available, this is another interesting option that could be very helpful. For example, when the table is so large, even if it is a dimension, but if you have a dimension with 20 million customers, for example, you might want to keep that dimension in the Lakehouse, for example. I will never spend too much effort deciding what to do with a table with 10,000 rows. I just import it. What's the point? But if a table has 20 million rows, I will balance. Depending on the refresh time I want, depending on many conditions, I could make a choice. So depending on the performance requirements, the organizational requirement, and many other requirements, that's just another option we will have available. So if I want to combine the best of Direct Lake and import mode, what can I do? What can I do if I want the tables that I want to modify in import mode, the dimension, product, date, customer, store, and I want to keep in Direct Lake the large sales table that doesn't need any transformation? Well, in that case, I could try to use the composite model, but the classic composite model has some limitation. Let me explain. So let's consider the 2 semantic models, one just with a table in import mode and the other in Direct Lake. So this way, I have to pay the price of importing the tables only for small tables, and I will just get the data straight from the Lakehouse with the transcoding for the largest table. The idea is that if I consider a model that has only the dimension, so you see that in import mode we could have only the product, the sales, the product store data tables, and sales for the Direct Lake model. And now I have these 2 semantic models published. I could create a 3rd semantic model that combines tables coming from 2 different semantic models. So this way I don't add additional storage. And I can create relationships between these tables so that every dimension is connected to the fact table. But by doing that, what happens? Well, it happens that I will pay the price of crossing the boundary of the semantic models each time I combine tables that belong to 2 different semantic models, which means every single time, which is not ideal because the relationships between tables of different models should have a very low cardinality. But we have, for example, customers that could have millions of customers. That's not a good idea. And so there's also the problem that these relationships are limited relationships that don't propagate the blank row when there is an invalid relationship, for example. So these are the limitations we have. But before looking at the final solution, let's take a look at how we can create a classic composite model for the scenario that I described, so we can also observe the performance issue. So this is a new model. I can just connect to the Power BI semantic model. I start, for example, with the demo import mode where I connect to the tables that I have in import mode, the dimensions indeed, and I connect, for example. That's an initial part. And once I have this, at the moment I don't have a semantic model, I have just a report connected to the semantic model. But if I click on make changes to this model here, for example, or any other feature that will transform this model into a local model with connection, not this model, this report into a local model with connection to the remote model, then I can choose which tables I want to keep in this composite model. And from the import mode, that if you remember, the import model doesn't have all the transactions in sales. I import only customer, dates, products, and store, for example. Then I submit, and then I add another table from the semantic model. So I can go back to OneLake catalog as soon as I have these tables ready, and I import from Power BI semantic model, this time using demo Direct Lake. Demo Direct Lake, here we go. And I connect again. This time I choose only the table with sales and potentially the table with the measures. And I click submit. Now I have all the tables. Now I have to create the relationships, and the relationships are all limited relationships because we cross the boundaries of two different semantic models. I will not complete this part now. I just want to show you where we are. We have the sales table that must be connected to dates, customers, and store. And I'm not going to do this now because when you created the relationship, the validation of the relationship is very, very slow for this model, and it will take too long. So I prepared this upfront. I suggest you, this will be fixed hopefully, because even if I skip the validation, skipping the validation actually canceled the relationship. This was a bug in March and it's still a bug in May, but hopefully it will be solved soon. If you have to do this and you still see that the validation takes too long, consider using tabular editor to create the relationships manually so you can skip the validation. And so I prepared the file with the relationship here. So you see that I have all the relationships between these tables that have different colors because they belong to different semantic models. And these are relationships that indeed connect to different semantic models and allow me to create the report that I want. Because I have the price range in the table in import mode, I still have the price range valid here. And what I can observe though is that the cost for producing this report is particularly high. If I go to the performance analyzer and I start the recording, refresh visual, and I see the cost for populating the matrix, I see that this DAX query takes a relatively large amount of time. So you might say, okay, now we had the cache, so this was not too bad because we had the cache. But if I copy the query and I go to DAX Studio, for example, I can analyze the code generated to solve the query internally. So if I use this query is what is used to populate. Let's remove this one, sorry. Just the first one. I don't want the direct query here. Oops, sorry. It's a little bit slow. Let's see if I can fix it. Oh, well, but actually this is good because we can see. So the problem is the following. Until line 30, this is the query generated for populating the visual. But the lines below contain the content of the query sent to the other semantic model, because the local model generates queries to the other semantic model, which are different DAX queries. So the initial query is sent to the local model creates queries dispatched to the other models, and these queries are very, very complex because these are the relationships that had to be included to perform the transformation. So if I remove everything here, and I start the server timings query plan, and I run the analysis of the performances of this query, you will see that in the server timings you can see, let's go here, that these are the queries generated to solve this query. 1, 2, 3, and 4. And this one is particularly expensive because you see that this long list of numbers is the description of what we have in one of the relationships that we are executing. And this is a simple one because this is just for the price range. a simple list of products. We have just a few hundred products. If you have millions of customers, forget using this technique, because the query will be just too long having the list of the customer to move through the relationship that crosses the boundary. So that's the reason why using composite model, and I go back to the slide, using composite models can be not the right thing to do if we want to create relationship between the fact table and the dimension, because we usually use relationship that have not a low granularity, but a medium granularity. Also, thousands, tens of thousands is already a little bit too much for a composite model in a relationship that traverses the boundaries of two different models. So for this reason, we have to see the best solution, which is Direct Lake+Import. Finally, we describe Direct Lake+Import. This is a new feature that has been released just a few days ago. I am recording this session at the beginning of May, and this feature is now available on all the Fabric tenants. So how does it work? Well, the idea is that we have seen that if I have two different semantic models, one in import, one in Direct Lake, we have a different behavior in the two systems. But basically, we're saying that all the tables that belong to that semantic model are either in Direct Lake or in import mode. The difference is that in Direct Lake+Import, now it has been enabled, at least at the engine level, the ability to choose for every table to be either in Direct Lake mode or in import mode. So table by table, you can make choice. You say, okay, this table, fact table large, Direct Lake. This other table, small, import mode. And if it is in import mode, you have access to calculate columns, calculate tables, Power Query, everything. Now, of course, what happens is that when you do the refresh, the tables that are in import mode are refreshed completely, so they are read from the data source and compressed in memory, and the tables that are in Direct Lake mode, you only have the refresh of the model metadata and then the transcoding when the column is used again. But if you use Direct Lake+Import mode, you also have the option to have additional data sources for the tables that you want to import. So that's good news, because you can also mix a table that comes from I don't know, a CSV file, for example, that you don't have in Direct Lake. So actually you can combine different sources as you want. Maximum flexibility. So you're not forced to put everything in Direct Lake. And so in many cases, this could be, you could have other reasons, not just the performance one that I'm mentioning now, which is the main driver for the choice. So let's take a look at how to create this model, and then we will recap the consideration about this new model. Remember, this feature is in preview, so many details could change, especially for the user interface, and you will see that probably I have to do some gymnic about the user interface and different tools that I have to use. Hopefully, when this feature will evolve during the preview, it will be simpler to use, also just using Power BI Desktop. You will see that I had to use some other tool now. Anyway, so where do we start? So because I want to combine Direct Lake tables with import tables, I have to start from Direct Lake. So first of all, Direct Lake. So I create I create a model importing a table from the Lakehouse, and I go to my Contoso Lakehouse. I connect to OneLake, same demo as Direct Lake. The only difference is that because I need only sales, I will import only one table now. So as soon as I have the available list of tables, I will choose sales. I will rename sales with the uppercase, and then I will import the measure. So here we call this demo Direct Lake import single word, so we know that there is no Direct Lake import. Okay, Direct Lake should have this one, Direct Lake import. Okay, it doesn't exist, and I import sales. Remember, by doing this, I created the semantic model in Power BI service. I will not have a local version of the model. So I click OK, and then once it is imported, I will rename sales into uppercase sales. I mentioned this just because I want to highlight that there are a few transformations, small aesthetic transformations we can do in the semantic model, but not too much because we cannot go deeper and do changes in the transformation, of course, because otherwise we will not, it will not be direct. So I go here, I change the uppercase S here, and this is done. Second point, the measures that I want to create, if you remember, I imported measures, here we go, with a Tyndall script. And if you look at these measures only reference sales. There is no reference to any other table. So these measures can be stored in the same model, can be defined already, just having sales, because they don't depend on anything else. So if I do this and I refresh this calculate table with the measure definition, I remove these two warnings. Now I go back to my model. I have here the sales table and the M table that just contains the measures, and everything is good, so I can move forward. Now, remember, this is already published into the model, but now I had to extend the model by adding tables. And how do I do that? That's a tricky part. So ideally, at this point, I should import the tables using Power BI desktop or something else. Now, I don't have the user interface that supports me, but if you remember, in the first demo, I created this model, okay, demo import. So demo import has the actual connection to the SQL endpoint that is still published on the same Fabric workspace. So if you think about the problem, if I imported a table that is local, because I'm creating a model in the cloud, it will not work. So the assumption is that I have to create in import mode something that retrieves data from something that is available in the cloud. A SQL endpoint is good. It could be a MySQL, Oracle, whatever, an Azure table, so whatever you have on the cloud, so that the refresh will be able to work. We have this here, so this is something I can use. And the problem is the user interface, as I said. And the best user interface you can use today is Tabulator. I hope that I would have been able to use the Tyndall view, but there is still some limitation in a Tyndall view that does not allow me to paste into the semantic model in the cloud, the Direct Lake semantic model, the tables that I want to import. So this is what I'm gonna do with Tabulator, but remember, this will be possible hopefully with some other native Microsoft user interface. There is another workaround today that you could use with SQL Server Management Studio, but really, I will not. I tried it. It could work. Is way more complex than that. If you don't have Tabulator 3, that is the commercial version, you can use Tabulator 2. The user interface is the same. The feature is available the same as I'm showing you now. So this is the Tabulator connected to the import mode, and I want to connect. So if I go to the other file, let's see if I have the file here. Give me 1 second. I have the demo Direct Lake import. This is the one that I open now. Demo Direct Lake import is the one that I created now in Direct Lake. And I open Tabulator for this demo Direct Lake import. So now I keep two different instances of Tabular Editor open on the two different semantic models. It is opening, 1 second, and I will show you side by side the two tabular editors. So 1 and 2, here we go. So now we have Direct Lake here on the left, import on the right. So what I'm gonna do, I'm saying, well, I want to get customers, dates, products, and stores, okay? I want to copy these tables here in tables, edit, and paste. Okay, so I copy the table, the definition of the table, from one model to another. And then I save all here, okay? Save all. Okay, so now I'm pushing to the Direct Lake model, the one in Power BI service, the definition of these tables that I want to import. Now there is a problem. At this point I should refresh the model, but I cannot refresh the model if I don't fix something in the semantic model first. Let me explain. I open the connection to the workspace where I published this model. So this is called, we said, the demo Direct Lake+Import. So demo Direct Lake+Import. So I open the semantic model demo Direct Lake+Import. Now in this semantic model, actually I should have went to the settings. Let's see if I remember. Okay, settings. In the settings of the semantic model, I have these so the connection to the mapping to the connection here, where I can specify that you see that this Azure Data Lake storage, we want to keep it with the single sign-on. This is the security that goes to OneLake. That's fine. But for the import mode, because the refresh will be executed not with my interactive user, long story short, we have to create a connection here. So basically, we have to map this into a connection where we can provide, for example, this connection is Contoso demo Direct Lake. Okay. This is the definition of the server, and the authentication method is OAuth20, and I want to edit the credentials. So basically, I have to provide the credential that I want to use when this refresh will happen. So at this point, if I made everything correctly, I go back here, and now I use this mapping. So Contoso demo Direct Lake will connect to that one. So I click apply, and at this point you see that we have this credential that is managed by connection Contoso demo Direct Lake. So this is a little bit problem. The first time I had to prepare this demo, believe me, I spent hours to understand that. I had to talk with Microsoft. Hopefully this will be easier when this will be in preview, but I mean, it's just the first time. To be honest, the following time, once you have, if you remember, if you have seen, I already had this Contoso 25 that I used in Vegas. I could have used that, but it was connected to another example, so I prefer to use a new one. And then I'm talking because after you created that, you should wait a few seconds because it takes a little bit of time to propagate. And if we wait enough time, hopefully this time I waited enough, we can just go to this model and say, I want to refresh the model. So if I refresh the model through Tabulator, I'm saying I want to do an automatic refresh. So I want to refresh the tables that are not ready. And if I go to the refresh queue, I can see what happens. Now, I mean, it is a little bit small, but if you see here, data refresh failed. Probably this demo works one time every 10 probably. The best thing you can solve, the best way to solve this problem is to do the first refresh straight on the Power BI service. Remember, it is in preview, so usually I'm not so, let's say, I'm more hard on a feature, but this time we can understand. So it's still in development, so it's still not ready. So let's go back to the list of the semantic models. So the demo Direct Lake+Import, and I refresh now. So hopefully the refresh is working. No, it's still providing an error, an internal error with the authentication. So let's try again to see whether I have to edit the credential, because now we have the data source credential here, but this is already managed, so it should work. That could be just the problem of the refresh time. As I said, it takes time, and I wanted to keep this example here, because if you try by yourself and you are not aware of this problem, you could say, oh, it doesn't work, and you stop trying. It's just a question of time to wait, hopefully. And so we can try again. So if I go back to the previous visualization, I go here, demo Direct Lake, import, and I refresh. And now hopefully it will work. You see, it took like a three minutes, maybe 4, something like that, but now it's working. Now, when it starts to work, it works also with Tabulator. So you see that there are no errors now, which means that if I go back to, for example, here, Tabulator, and I refresh again here, model, right-click, refresh and automatic model. You refresh queue. Where is the refresh queue? Let's open this here. Okay. You see that now the model refresh, I think this one is the old one, and this one should be the one that completed now. So if I clear completed and refresh again, just to make sure, automatic. Here we go. 1, 2, 3. Good. So now we have a working stage. I know it's a little bit boring, but I would have I probably have cut some failed demo in other parts of the video, but not here, because here I want to make sure that you are able to create this by yourself. So that's the more critical part. Once we go through this critical point, which is the creating the connections for the refresh that will work in the model that also has Direct Lake, now we can move forward. We can move forward because now the model doesn't have relationships. We have to create the relationships. And for the same reason I didn't show you in the composite model the creation of the relationship. The creation of the relationship might have some issue in Power BI desktop or in Power BI services. So I prefer to create the relationships from here. So I create the first relationship from table sales, customer key to customer key, many to one, enable, okay. Then I create the second relationship that is from the table sales to dates through order date to date key. Sorry, not net price, but order date and date, not because it has to be a date column. And this is enabled. Then I create another relationship between sales and products through the product key, product key, column here. Okay. And finally, the store. So relationship, sales, store with the store key and store key. So sorry that this stores, I cannot see that, but after more than 1 hour of video, I don't want to repeat everything. Now, I created the relationship, but remember, when you do some change like that, you have to refresh the model. But this time, if I do the model refresh automatic, only the relationships will be updated because the tables didn't change. So, oops, now we have a problem, duplicated value. Ooh, I made some mistake here. Customer key, order date, product key, customer key, store code. This is a mistake, so let me fix it. So this is store key. Okay, and let's try again. Yes. Saving changes, refresh. This refresh should be very, very quick because it only refreshed the relationships. Here we go. You see that only the relationships have been updated. At this point, because I created the relationship, I refreshed the model, and I can take a look at the content of the rows in product, for example. If I go in preview data, because this is a table that has been imported, I can refresh it. If I try to do the preview before the refresh, I would not have seen any data. So I can see that something is working. And at this point, I can just create a new file in Power BI Desktop. So let's create a new file. New date. Okay, can I create a new file here? Blank report. Sorry, it's after more than 1 hour. I was looking for new, but actually it's just blank report. I go to the OneLake catalog, Power BI Semantic model, and I will look for the model that I created now. So demo. Direct Lake+Import mode. Direct Lake+Import mode. So this is the model we created that combines the two. I connect. And here we go. We have our sales amount, the margin. Let's create a table. Let's create a table here. Direct Lake. So the first time it takes a while to load some data. Let me check what happens now. That's not good. So let me try again. Sales amount. Maybe that because I moved too fast something. That's the risk of using features in preview. And in theory, yes, it works. So let's remove this one. So I transform this into a table, and let's increase the font, and let's include also the margin percentage. And then we want to use, for example, the products category name, something we used before. and you see that it takes some time the first time, because again, it's always the problem of loading something for the first time will require latency for the transcoding. But remember, we're working with a sales table that has 100 million rows. Importing a table with 100 million rows would have needed minutes, maybe 20, 30 minutes locally, maybe less in the cloud, but still much more time. We never had to do this. So yes, we wait a few seconds, but remember, the transcoding takes some time. So it's not immediate, but we didn't pay the price for the full refresh. Now, the last thing I want to show you is the following. So how can I demonstrate that this is working better than the composite model I shown you before? Because we said that this is like another type of composite model. So this model is published on the cloud. So if I open DAX Studio and I connect DAX Studio to the model we have on the cloud, this is clearly, this is not possible here because this is not a local model. So I have to create this going to demo Fabric, if I remember well. Fabric. I connect and I authenticate with my account. And then I finally, well, it doesn't get the workspace. Fabric demo, that's the problem. Fabric demo, not demo Fabric. And let's try again. So I'm doing this demo to show you what happens in the storage engine. I want to show why I'm tolerating the absence of user interface for many features, because this is a game changer in a few scenarios. If I get, I prepared the DAX query that is relatively simple. So I will show you the result of this query, but before executing this query, I want to enable the server timings and the query plan, and then I clear the cache on run and I run the query. So what I'm going to show you, if this works, let's see if this is, oh, because we changed the name to products. We have products. Run again. Here we go. So this is what happened at the storage engine level. So the query made a single request. So first of all, the result. So the result is combining in the same report sales amount, which is the aggregation of data from the sales table, and the result of the calculated column price range with a price range order that is connected through a relationship with sales. So we have two tables involved: sales, Direct Lake, product, import mode, because we're using price range, which is a calculated column. How this query is resolved? If you remember the composite model, there were a lot of DAX code to transfer the relationship between the two semantic models. Now we have only one storage engine query. This one, this row, let me highlight this. This row is a single storage engine query. And this storage engine query is, let's show it here, is made by a single XM SQL code that combines sales and products in a join in Vertipack. From the Vertipack point of view, Vertipack is the storage engine used by Direct Lake. Even if we have one table in import mode, one table in Direct Lake, from the Vertipack point of view, they are both in import mode, or if you prefer in Direct Lake mode, as you want. But the idea is that this is the best possible performance you can get in Power BI, also in analysis services. But combining, joining two tables that are part of the same storage engine, like in this case in Direct Lake and import combined together. That's the reason why this query is extremely fast. And this is what I want. I want to have the flexibility of Direct Lake for large tables. I want to get the flexibility of import mode for the dimension, because I want to change the content of the table in the dimension. I want to add the price range, for example, without asking the data engineer to prepare something for me, but I don't want to spend too much time loading a lot of data in import mode in the Vertipack engine if I already have a copy of compressed data almost ready in a data table in a Parquet format in practice. So let's go back to the slides 1 second. So let me find the slide. So I want to recap the Direct Lake plus import mode that we described. So this is a new type of composite model that actually combines the best of the two worlds. And Direct Lake is what I would use for large tables or tables that change very often, and I don't want to import every time, even just for a few million rows. And we have a minimal refresh time. We have the we cannot extend the table with calculate columns and so on, but usually we will not do the same also for import table because we don't want to create calculate columns on very large table, for example. And we can keep in those tables the measures that aggregate. So we aggregate data that are in Direct Lake, that's not an issue, but then we import the dimensions, the tables that describe the attributes of what we want to aggregate, because that is where we will apply most of the changes based on the business requirements, and we don't want to depend on other people in the company. We want to shorten the time to be able to deliver new features in the semantic model. We have access to all the features this way. We can do calculate columns in DAX. We can use Power Query. You can use views in SQL. You can use whatever you want. You can also get data from other tables that are not even in the Lakehouse or warehouse. It just works. And the refresh time is reasonable. It's reasonable because usually these tables are small, and if you have user hierarchies, they will be visible in Excel too. So you have all the features also from a client point of view, also in Excel. So that's the power of Direct Lake plus import mode. So it has been a very long session. I know it has been much longer than the session I delivered live. A 1 hour session in Las Vegas became a much longer session recorded. But I wanted to show in more detail a few things that live I should have skipped because of time. So I wanted to make you able to repeat the same test with your own model, going step by step. So let me recap what we have seen. So import mode, the best, right? The best for the performance, the more flexible, but yes, you have to wait to refresh the data, to load data in memory, to compress the data. It's easy to use because you don't have to pay attention to how you compress the data, but of course it requires time, especially for large tables. Direct Lake doesn't have the refresh time, even if you still have to load the data into the Lakehouse, and you have to prepare the model that is good for the semantic model. The data model that you use in the Lakehouse or the warehouse must match the physical model of the semantic model 100%, which means that you move to the data engineer the operations to prepare the data for the semantic model. And this could be a problem, especially for the dimensions. While it is potentially good for the fact table, because usually we don't need to extend the fact table too much, but we often need to change the content of the dimension based on business requirements. So one solution could have been the composite model, but the problem of the composite model is that it can actually mix import mode and Direct Lake, but not in an efficient way. The relationships between different models are expensive and don't have the same feature, especially if you have an invalid relationship with data on the many side that doesn't match the corresponding numbers, the corresponding keys on the one side. Best of both worlds, Direct Lake plus import mode. We classify this mode as a composite model, but actually it is a single model where we just change the storage mode of each table. So in a way, even if we have different storage modes for different tables, what we have is a single island, is a single, we call it continent, a vertical continent where all the tables share the same feature from the vertical standpoint, and the relationships can be regular relationships with the same performances and the same features of any relationship you have in import mode. So that's the reason why, even if it is in preview, we have seen the development experience is far from ideal. I had to use a few hacks, a few back and forth between different environments to make it working. It will be better, but that's definitely something you have to look into because it's going to be probably a very good solution for many scenarios where the fact table is very large and you want to have more option to adapt the semantic model to the requirements for your business. And as usual, enjoy DAX and the semantic model.